For this next example, we are going to ultimately do partial fractions. But in this one, we're given x cubed over x squared plus 2x plus 1 and asked to integrate that from 0 to 1. Here, the degree of the numerator is 3. Degree of the denominator, though, is 2. So we can't move into partial fractions just yet. First, we need to divide this out. So I'm going to use long division. And I will use a couple different colors here just to distinguish everything, because I'm going to do long division, and then I'm going to do some partial fractions, and then we will actually integrate the whole thing. So starting with the let me rewind that. Starting with the long division, not the partial fractions, we're going to take x squared plus 2x plus 1 divided into x cubed. So I'm going to go ahead and just put zeros in as placeholders for the other terms here, working my way down. So x squared into x cubed goes x times. I'm going to multiply that x, so we get x cubed plus 2x squared plus x. Now I'm going to subtract. So I have a negative 2x squared minus x plus 0. X squared into negative 2x squared is going to be a negative 2. So we have negative 2x squared minus 4x minus 2. When I subtract, I'm going to change my signs. So I'm left with 3x plus 2 as my remainder. So that's going to be 3x plus 2 over the x squared plus 2x plus 1. So now I can rewrite this. We're going to integrate from 0 to 1, x minus 2 plus 3x plus 2 over this denominator. And if you factor x squared plus 2x plus 1, you're going to get x plus 1 times itself, so x plus 1 squared. So this example is a little different from the one before in the fact that we had to do the long division first, but also that it has a repeated factor there. The way we'll do partial fractions for this one is I'm going to let a be over x plus 1, and then b is going to be over x plus 1 quantity squared. So I'm switching colors again. I'm going to work down here for the partial fractions. So the x minus 2 can leave that be. We can just integrate that. That's really easy. But looking at the fraction, I've got 3x plus 2 over the denominator. So again, I'm going to write that as a over x plus 1, just this factor to the first power, and then b over that factor squared. So just like with the other examples, I will go ahead and multiply through by the common denominator, and that's going to leave me with 3x plus 2 is equal to a times x plus 1 plus b. And again, you could work this with two equations with two unknowns, or you could use that little shortcut that I went through in the last example, and I'm going to do that little shortcut. I'm going to start by letting x equal negative 1 for the simple reason that it's going to wipe out kind of this middle term here with the a. And if x is negative 1, then I have negative 3 plus 2, which is negative 1. Like I said, this is going to go to 0 equals b. So now we have a value for b. I just need to find a value for a. To do that, I'm going to let x equal 0. And if x is 0, then I have 2 equals a plus b. And I know that b is equal to negative 1, so 2 equals a minus 1. meaning that a equals 3. So now that I have my values for a and b, I can come back up here and break down the 3x plus 2 over x plus 1 squared into these partial fractions. So I'll go ahead and do that now, and then we can integrate the whole thing. So I've got x minus 2 plus 3, that's a, over x plus 1, minus 1, there's my b, the negative 1, over x plus 1 squared, dx. Now, you could break this into 4 separate integrals, and I actually did that in my paper notes if you want to go look, but you don't have to. And so for this example, I'm just going to integrate everything here all together. So the x is going to give me x squared over 2. Then it'll be minus 2x when I integrate that. Moving here to the first fraction, since that x plus 1 is to the first power in the denominator, we're going to have the natural log. So it's going to be 3 times the natural log of the absolute value of x plus 1. For the last one here, let me go ahead and write the minus. I've got x plus 1 squared in the denominator, so that would be x plus 1 to the negative second. I can integrate that with the power rule, so it'll give me x plus 1 to the negative 1 power divided by negative 1. That divided by negative 1 is going to turn this negative to a positive, so I'm left with 1 over x plus 1 to the first power in the denominator there. So we're going to evaluate this at 1, and then we'll subtract and evaluate at 0. So plugging in the 1 first gives me 1/2 minus 2 plus 3 times the natural log of 2, absolute value of 2 is still 2, plus 1 over 1 plus 1, so plus 1/2. Then minus, I'm going to do the same thing with the 0. So the first one, 0 squared over 2, that's still 0. 2 times 0, that's still 0. Here I've got the natural log of 0 plus 1, the natural log of 1, that's also 0. Finally here, I've got 1 over 0 plus 1, so that's just a 1. So 1/2 and 1/2 give me a 1, so I have 1 minus 2 plus 3 times the natural log of 2, then minus 1. Your 1 minus 2 minus 1 is going to give you a negative 2, so you could write this as negative 2 plus 3 times the natural log of 2. And if you don't like having a negative to start out your answer, you could write it as 3 times the natural log of 2 minus 2. You could reverse the order, no problem there.